Right, are we ready for the next one? What is the alpha scattering experiment that Rutherford did? Very simple experiment. Can you look up and I'll show you. So what Rutherford did was he had some gold leaf paper. So what is gold leaf paper? It's just gold paper. Very, very thin, fine gold paper. So the paper is lots of gold atoms together. So you have your gold atom, and then around the atom you have is electrons, and then you have another atom, and around it is the electrons, and so forth. So this is gold nucleus, and then this here would be the electrons. And he took an alpha particle. An alpha particle is helium-4, and you know its charge is positive. Okay, so he fired the alpha at the gold, and some things happened. Sometimes the gold would hit this positive proton and would come back. Okay. Sometimes it would get close to the electron, and when it gets close to the electron, what happens? It gets pushed away. So it would move this way. It's like if the electron pushes it out of the way because they're both. Oh, sorry, I have it the wrong way. The electron pulls it in, so it would go like this. Because the electron pulls it in, because it's a negative and it's a positive. So he did this many times, and sometimes it would go through and not be affected so much. And by examining all the angles, these are called the scattering angles. By looking at the angles and using some trigonometry, very advanced trigonometry, he was able to work out that the electron must be around the proton. Before this experiment, people weren't sure. Maybe the electron and the proton were mixed together inside the atom. But this experiment confirmed that the electron is outside the proton and the electron is smaller than the proton, and so forth. So in other words, this experiment confirmed the hypothesis that the electron orbits the proton. So this experiment confirms that the much smaller electron orbits the proton in the atom. Yeah. I think there's another experiment as well that shows the electron is 1,000 times smaller than the proton. But what he achieved in this experiment, the result he got was just by using the math calculation that when the alpha strikes the proton, it can bounce back. But when the alpha strikes the electron, because the electron is so much smaller, it can't really do anything except kind of push it out of the way. You know, it's not big enough to do anything significant. If the, by the way, if the electron was much bigger, I think it would. Simply put, there was a lot of complicated calculations from all the measured angles, and the only result that would be consistent with all the angles would be a much smaller electron orbiting the proton. There's no sort of, it really is, here are all the calculations, it must be this, it can't be any other picture, you know. It's not really as simple as, oh, because this and so this, you know. Lots of, a lot of these experiments around about the time 1900s, required a lot of maths and a lot of calculations, because you're dealing with something which is atomic, so you're going to have to use, perhaps a few hundred measurements to try and get a result. Because each measurement, I imagine, would be so unreliable because it's so small. Certainly the case when Einstein calculated Avogadro's constant, a lot of measurements would be needed, or when the value of E was first calculated, maybe 100 observations were required. Okay, is that state the experimental observation of the scattering. Based on these observations, what deductions can be made about the nature of gold atoms? There you go. That the smaller electron orbits the proton. So this kind of answers part A, and this answers part B. I better say something more about part A. What can I say here? The positive fired alpha, flip it, is scattered by the electron and repelled by the proton. So the alpha bounces back on the proton and is deflected by the electron. It's also deflected by the proton too if it just about misses it. Like if it's like here, it'll be deflected too. Scatter is a word we use in English when one thing pushes another thing off its path and makes it move in a different direction. There was lots and lots of calculations to prove this result. It requires a lot of trigonometry. You might have talked about this in chemistry, the model of the atom. Did you talk about the different models that people had of the atom before it was discovered? No. Are you sure you didn't? Are you sure you didn't? It sounds like something you would discuss in chemistry. So we have the current model, which is the electron around the proton and neutron, but the first model, the Plum model? No, okay, the first model was that the electrons, protons and neutrons are all kind of mixed together in like bread. Yeah. Did you do this in chemistry class? But you know of this idea, yeah. So if it was all mixed around like that, then you wouldn't get these scattering angles, because it should just, if it was all mixed together like a bread, then it should really just kind of hit it and bounce back, and it shouldn't really deflect so much because the positives and the negatives should cancel out to give it not much of a total charge when you're nearby. Whereas if the electron is separate from the proton, you could have a deflection if you were near the electron but not the proton. Yeah? Anyways, that's that one. Okay. 4 marks. Right. How about, when's our next physics?
Tomorrow. Is it?
How many of these questions do you want to do tonight, and then I'll do them in class tomorrow?
1.
That's fine.
Stable, but we have plenty of time, so.
Yeah, so do you just want to continue working on these in class?
Yeah.
Yeah, like how we did today?
Yeah.
Yeah, okay, fine. So we'll continue with this tomorrow?
Not tomorrow.
Whenever, Wednesday then, the next class. Okay. These have all been uploaded already. Can I close this?
Are we going to the last question?
We're going to do everything in this.
Oh, yeah.
Why are you elected?
Finish the project.
That doesn't mean you know anything.
Well, I mean, finally,
Finally finished.
yeah.
Those 25 weeks nearly killed you, did it?
Just focus.
Can I close this tube?